Lab 1, Charge Tape Lab. In this lab, we are determining approximately how much excess charge is on a piece of charged tape. The charge on the tape required to suspend the other tape above it, floating with a zero net force acting on it. The main concepts covered in this lab include Newton's second law, the momentum principle, point charges, electric fields, and electric forces caused by these point charges. And the formulas for the three are shown. The third formula on the right says QB squared because in this lab we can assume that both charges on the tapes are the same. So substituting in the electric field formula into the electric force formula and simplifying, we can get Q, just the charge of one of the tapes squared. Now, the initial expectation we have for bringing two U tapes near each other is that they should repel each other. And the observation in the lab was that they do in fact repel each other. Also, a single U-tape is attracted to other neutral objects such as my desk or a book. To determine whether the U-tape was positively or negatively charged, our expectations are as follows. We can say that if a U-tape is positively charged, it will attract the pen with a negative charge. If negatively charged, then they will repel. And a neutral U-tape should go towards the charged pen. Now, to observe what was true, we can charge a pen, give it a negative charge by rubbing it on cloth or hair. And bringing the U-tape near the negatively charged pen repels, actually. So from that, we can say that the U-tape has a negative charge. The net force Y component in the floating tape portion of this lab is seen to be 0. This is because as the floating part of the tape B in the diagram as shown, is floating in the air suspended. This means that there is two main forces acting on it in the Y direction. The electric field force from tape A pushing it up and the gravity force pulling down tape B. These two forces will balance each other out since the tape is suspended, giving it a net force of 0. To find the gravitational force from this, we need the mass of the tape. And the mass of the tape is given to us as being 0.002 kilograms. Now, to get the gravitational force, we can multiply the mass of the tape by the gravitational acceleration, which gives us 0.00196 newtons. Now, to find the amount of charge on one U-tape, we can assume that the U-tapes have the same net charge, and we can also treat each tape as point charges. The gravitational force for this is 0.00196 newtons as calculated on the previous slide, and the measured separation distance between floating tapes in the lab was 0.038 meters. The Coulomb constant value is 9 times 10 to the 9th Newton meter squared per Coulomb squared. Plugging in values and solving for Q in the expression shown in the bottom left, in which I equate the gravitational force to the electric field force to calculate the charge value, Q, gives a Q value of 1.773 times 10 to the negative 8th coulombs. In the next expression on the right, we can plug in the Q value, 1.773 times 10 to the negative 8th, divided by the charge of an electron to get the number of excess electrons, which is 1.108 times 10 to the 11th. Now, the area of the sticky part of the tape that we can calculate, which with approximately 20 centimeters of tape, was 0.002291 meters squared. The approximate surface area of an atom is that we can use is 1 times 10 to the negative 20th meters. And dividing the total area by the area of an atom gives 2.291 times 10 to the 17th atoms on the sticky part of the tape. Now, to calculate the ratio of atoms on the tape to the ratio of electrons on the tape to the atoms, we can divide the number of electrons calculated previously by the atoms on the sticky part, giving us 4.836 times 10 to the negative 7th electrons to atoms on the tape. Now, for my computational model, these are the main chunks of the code that make up the main parts of the code, right? So this is the function that I created to calculate the electric force. And in this, we can see that I calculate the electric force and output electric force in R hat from this formula. And I run that, I made a function so I can run it multiple times, multiple iterations, and I calculate two different electric field forces, one for the first tape, top tape, and one for the bottom tape. Finally, I draw three arrows. I draw three arrows to represent three different vector forces, two from the electric fields going back and forth, and one for the gravitational force pulling the top tape downwards. As we can see in this diagram right here, the orange arrow is actually the electric field force from the bottom tape, which is the bottom blue sphere right here, pushing the floating tape up. The yellow arrow is the gravitational force pulling it down, and the green arrow is that of the electric field force on the bottom tape due to the top tape.